Hello and welcome back to the wiring diagram version of the European Autocraft Studios. Little tutorial on the early wiring diagrams. Last week I went over some of the numbers on the wiring diagrams that indicate power, grounds, things like that you can follow inside the wiring diagram. That'll take you to certain places and give you an idea. Once you see it, you know 30 is battery voltage. You know you're going to have battery voltage there with the ignition off. But first, take a look at our awesome wiring diagrams that my IT department put together. These are taken out of the workshop manual, pieced together, because when you do them in PDF, you never really get the whole page. But they were put together beautifully. You could barely see the seam. They're excellent. When we're done with this tutorial, we'd like to give these to one of you subscribers, all rolled up nice and neat, the whole package, including the additional current flow diagrams over here. We have to work out and figure out how we're going to give these away, get the details all sorted out before we can give them away. So let's get started. We're just going to start with 30 power right now. Up in the fuse panel, remember all the top is a fuse panel all the way across. This is where the power comes from, and the grounds are at the bottom. The grounds, remember, are 31. But let's start with 30. This is the battery voltage. If you look, here's our battery right here. Goes right up into the fuse panel. On the back of the fuse panel, there are terminals H. These are very large terminals on the back. There's some large and there are some smaller ones, but they're all 30 power. But these go to the large one. Look at the wire size. I'm going to call these 4mm. I believe it's a 4mm cross section, as if you cut the wire and look straight in on the wire end, you'll have a 4mm of surface area. I don't exactly remember that. I think we'll just call them 4mm so you know they're about the same. This is what powers our 30 bus. This is inside the fuse relay panel. This is all internally connected. We can follow that along. So we have two that go into the battery, up to the bus, and then we have what looks like a 16mm. This goes from the battery right to the starter. From the starter, we have another cable. This is a 1mm cable, 10mm cable that goes all the way across and comes off the generator, alternator. All live battery voltage all the time. These are very heavy cables. I'm sure you know what a battery cable looks like. While we're here at the generator or the alternator, we have the D+. This goes up to the, also goes up to the fuse relay panel. It'll always be a blue wire, always. The D+ is always blue. That'll go to the indicator light, up through a couple of terminals. We'll get to those in another tutorial. This goes up into the back of the fuse panel. C connector. I forget what color it is. There's colors for each one. It's not important right now. So it'll go into the terminal block C, pin 2. We also have outputs here, block A and block G. Terminal A and terminal 5. So plug A, terminal 4. Plug G, which is in a whole other section, terminal 5. It's convenient to have it all laid out like this, so you may have C terminal, H terminals all here, but they're actually spread out around the car. There's no wires coming off of these yet because it's not relevant to this page, so you don't have to worry about those. We're looking at the power supply, motor electronics, digital motor electronics, and fuel pump. That's all you're going to see on this page, unless you have something that moves over to another page. Here we have a couple. We have a connector here. This is the oxygen sensor. Heater for a California car. 83, the US cars only have a single wire oxygen sensor. I'm going to get off on tangents here. It's just my nature. Sorry. Anyways, so we'll follow these shortly, but let's stick with 30 power. What else do we have for 30? Nothing else on this page. Everything else is either on starter terminal, 15, which is ignition on, and that's it. So we'll get back to those. So on page 2 here, back up at the top of the fuse panel, we have terminal 30. Comes out of connector D3. Connector D, terminal 3. Whatever color that connector is, there's all different colors, like I said. This comes down to the headlight switch. So it's a red wire, 1.5 millimeter, so we know the approximate size of the wire. And then it goes into the headlight switch. This is now live all the way with the ignition, with the light switch off. This is in the off state. We see that this is power. So all the way down through this terminal here, it's a 6-pin terminal, pin 2, and they put an A. This means that this is one of 6 terminal connectors throughout the car. They're calling this one A. There's also a B, so it'll be terminal 6 terminal connector somewhere else, but it'll be labeled something different. And this goes down to our headlight, concealed headlight motor. If you want to, I will get into this circuit and how this all works with the light switch another time. It's a little complex, but it's pretty decent. It works very simple overall, if that makes any sense. We have, okay, so we have 30 power here, so this is live all the time. You put the headlight switch in the first position. All of these move at the same time. That's what this indicates. This means it's a manual touch. We turn the switch to the first position. Each one of these rotates one section. So here, this terminal will go to the 30 power, and this stays 30 all the way through. So this is live all the time from this point forward, from the on position to the 2 position, first position and second position. That sends voltage back up, current back up through the fuse panel, and goes off to our lighting and everything else it has to do with the key off. This also goes up to our parking light switch, parking light contacts. No more 30 power goes to this section of the switch, and up and more goes further on. All of these continue on somewhere else. We have the fog light switch. This is interesting as well, because with the headlights on, when you flash to pass, the headlights flash. But with the headlights off and down, with the headlights in the down state and off, when you do the flash to pass, the fog lights flash. That's a whole nother circuit that's controlled by this flasher blocking relay. More on that later. Let's move on to our fog light relay. Has power all the time. Well, why don't the fog lights work all the time? Well, they have to be on low beam for one. The fog lights will not work on high beam, so they use a relay. When you turn on the fog light switch, you turn on the relay, but the relay is only activated if the low beams are on. A whole nother mix of circuit there, but it's easy to diagnose if you have no fog lights, or if they work on high beam. That means somebody's either bypassed the relay or some other things have been done to make that work. Further along, again, 30 goes to a relay. Whatever relay goes here is not relevant to this page, so they don't show it. They only show the connections in the fuse panel. Same here, there's no relay symbol here. Again, another battery voltage. This is part 2, part 3. Here we have going through a fuse. Comes out of terminal D21, connector D, terminal 21, and A14. Connector A, terminal 14, not relevant to this, so it's not showing. Where does that go? Fuse, that comes all the way down and up into our emergency flasher switch. We know those have to work with the key off. So that's where our power comes from there. That gets a little complicated too, because in the switch in the off state, we have a turn signal. In the on state, it bypasses the turn signals and flashes both lights at the same time. That gets interesting too. If you disconnect the switch, you don't have turn signals. And the turn signals require 15 power because they don't work with the key off. So this is another little complicated circuit that requires both 15 power and 30 power. That's also fuse 8 amp, fuse number 6, fuse 7, down 30. We come all the way down here to the radio relay. As you know, on the early cars, 83, 84, early 85, if you pull the key out, the radio shuts off. You don't need to turn the key to the first position. That's like the accessory position, and that triggers this relay. We can get into that later, but where else do we have 30? This is 15, key on. We move down to the horn relay, 8 amp fuse, right to the relay in the fuse relay panel. This is 15 power. So the horn won't work unless the key is on.
Let's see. We have output from A3. I shouldn't say output. It could be an input, and I think this one is. So this comes out of A3, goes right back into A7. These are terminals, terminal block A, pin 7. So it goes out of pin 3, pin 7, and then it comes out E11, connector E, pin 11, all the way down to the horn contact. And this is, of course, on your steering wheel. When you hit the horn, it's grounded. So when you hit the horn switch, it takes this brown and blue wire. Now see the wire is brown with a blue tracer? It's brown because it's a switched ground. 9 times out of 10, you're going to see if it's brown with a stripe, it's a switched ground. So this is solid. I don't care what color that is because that's actually grounded internally through the steering column. Hit that horn and that'll activate this relay. But the coil of the relay is only live if the key is on. Yet the output of the relay is live all the time. So you'll have power at the relay terminal here, but not here with the key off. Power will be on both of them with the key on. 87 is the output to the relay. Comes out of pin terminal block A, pin 8, right down to the 2 horns, which are already grounded at ground point 4. This one is labeled as 4. And there's a section here that'll show you what ground is where. This is a ground cluster. You'll see other 4s, there's a couple of 1s, and those are groups of grounds that are on the body somewhere that we can show you. I'll probably have to show you on the 86 because we don't have an 83 here. We'll show you on the turbo project. So that's real simple horn circuit. Okay, on page 4, or part 4, let's see, we have power coming out of terminal H. This connects to the fuse and in the additional fuse panel, additional fuse board. That's the board, not the main board, but that's a separate board up on the right side of the steering column. I think it's a 10-part fuse holder. So we have 1 wire coming in. It's a 4mm, pretty big wire, and then 2 more going out. These go out to part 2, current track 11, and part 6, current track 7. We can get into how they transition from one page to another, but that's how you get from one page to another to continue on. Not everything is contained in one diagram. Sometimes you have to go to another diagram. So that's what those will do. But this goes through the fuse and powers a rear window defogger relay. So the relay will always have battery voltage, and it's switched through the circuit to turn on only with the key on. So that's the relay is controlled by when there's ignition power, but there's always battery voltage sitting there waiting. Further on, we have this one, ignition starter switch. Well, this is the feed to the ignition starter switch. Also a 4mm wire, comes out of terminal H again. Those are the big spade terminals on the back of that. They're not in a main connector, it's just they're big spade terminals. So that powers our ignition switch. This is in the off state. So the radio relay always has power. This is the entire bus inside, and it's moved when you turn the key. All of these move at the same time. You can see this one goes to X. We'll get to X in a little while. And you see there's nothing in the start position for this wire. Next one is only in the off position we have 12 volts here. We'll see what that does later in part 2. Why is there only power in the off position? And then 15, which is power in the on position and the start position. This would be the start position here. And then you come over to this terminal. This is 50, our starter, and there's only a connection in the start position. And all of this we can explain later. Terminal 15, okay, so that's to our ignition switch, and from there's a whole bunch of other stuff that happens. Moving on, 30, where are we next? This is part 4, part 5. Here, what do we have for 30? Nothing in part 5. Let's take a look here. We do have, we're in the instrument center console, so that's where our heater controls, the clock. Well, clock gets battery power all the time, right? So this one comes from part 3, current track 12. Well, let's take a look at that. Part 3, current track 12. That would be this one. This is power for the cigarette lighter and the radio relay. See, fuse 7 comes right out of here and goes to part 5, current track 7. Current track 7, part 5, and this is where it comes from. So we're getting 30 power here, even though it's not coming directly out of the board, we're getting it from the other part. And that's how we just go back and forth. Gets a little confusing, but it actually works out once you get to know it. So that was part 5. Really not much going on from the fuse panel out. This is part 6. We have one here. Additional fuse board. Now look at all the H's. Now we saw H's in the other parts, and each one of these was battery voltage. Each one, and these are large. See, this is another 4-gauge wire, a very big wire. Again, to the additional fuse board, number 3, 16 amp, red fuse. 16 amp red? No. Yeah, I think it's a red fuse, 16 amps. And this one is for our cooling fan relay. Cooling fans draw a lot of current, so they want battery voltage all the time at the relay, and then it's triggered by fresh air blower relay. Turns on the cooling fan relay. We also have a resistor and some other circuits that we can get into later on. So let's move on to, well, that's it for the parts, for the wiring diagrams, the normal stuff. Here we just have a quick indicator of what's what. We know that they're just saying that this symbol is a fuse. This is white 8 amp, red 16 amp, blue 24. Usually it tells you right there what the fuse is, indicating that this is the fuse relay board that we discussed. Wire connection on the fuse relay board, plug E, terminal 7. I call it connector, plug, whatever it is. It's the block that has many wires in it. This happens to be terminal 7 in that block. Down, continuation of wire. Like we discussed, this is part 5. It goes to part 5, current track 6. The letters I don't get because I've never seen them skew from the destination. If it's part 5, terminal 6, it has an A. I haven't seen an A anywhere else on the board that would match this wire, but not be in the same part. So I don't understand why it has a letter, but it helps indicate where it is, but it doesn't seem to go anywhere else. Yeah, wire cross section, 3/4 of a millimeter cross section, not diameter. I'll just call it that's a 3/4 millimeter wire, 0.75 millimeter. Makes it simple. No actual wire connection in between equipment and housing ground. Yeah, that's not real important to us. Body ground, current track number, we all kind of all understand that now. But we have a couple of additional current track diagrams. This was just for the radio. Here we have a 30 additional fuse board, fuse number 3, 16 amp, blue fuse. This goes to the power antenna. We know the power antenna is live all the time because you can take the key out and run away, and the antenna's still going down, still functioning. So that always has power there, but it's controlled by the radio. The radio has, as long as the key is in the ignition lock, it's the ignition lock relay. If you pull the key out, the relay shuts off, the radio shuts off, and power goes off of this white wire here, which is the antenna signal wire. So the power goes off, but the antenna is still powered. So this signals the antenna relay that the radio is no longer on, stash the antenna, we don't need it anymore, and down it goes. So that'll always have power to it. And of course our radio relay we discussed with authority terminal. Air conditioning. Believe it or not, some cars don't have air conditioning. Hard to imagine in Florida. 30 power here, comes down. This is our additional fuse board. We have a lot more going on here. This goes to these two fuses, air conditioner relay, comes down to the resistor pack. Oh, one resistor. Oh, that's for the cooling fan. Okay, that makes sense because the fan runs at a slower speed. And it goes to the cooling fan relay. We'll discuss this circuit later. There's a little bit more going on here than I can explain in this one at one time zone here. Wire connectors, like we discussed. T1 means it's a single pole. These, when we get to the next generation, the coordinate field diagrams, there's a lot more information than this. But two-pole connector, since there's so many two-pole connectors, they label them A, F, and L. So it'll be T2A, T2F, T2L, and you find them around. Luckily, they're telling you where they are, which is kind of helpful. There's so much more data in the newer diagrams. T3, three-pole air conditioner, and then the T6 near the fuse relay board. Not the additional fuse board, but this board, which is on the left side. Well, that's about it for 30. And power supply, 2 relays, and this power, a lot of the times the power stays stationary waiting to be used. They usually use some of the higher current stuff is live all the time, and then it's switched with a lower current through a relay. I'm sure a lot of you know what the relays do, how they work. Send me something in the comments if you want me to get into how the relays work. Pretty simple stuff. I can usually sum it up pretty quick. Some other things like the radio relay with the key in the ignition lock but not turned. It's this signal. What else do we have we can go over? All right, let's look at the X terminal. This is power with the ignition on, just like 15. So in the ignition on state, X is live, 15 is live, starter is not, of course, and we have 2 extra terminals that aren't used. They're not live either. But why do we have an X terminal? It's considered load reduction. Let's say you take short trips in your car and you have your headlights on, wipers on, your heater's on high. You make a couple of short trips, your rear window defogger is on. You come home and the next morning you go to start your car. Battery's not really up to par. It's charged, but it's not really charged because you're making short trips. All these power consumptions are on. When you go to start the car, the starter's requiring a lot of power. It turns off any consumer that is on the X terminal. I think we're going to find that the headlights themselves are on the X terminal. Your rear window defogger is on the X terminal. That means all these heavy power consumers will turn off when you go to start the car to give that starter a little bit extra current. So whenever you see X, that's a load reduction. That means it shuts off in the start position but returns back on when the key is back to the on position. You might even notice that with the blower on. I think the AC might do it too. Or the headlights. Put the headlights on and crank it. You see the headlights go off while it's cranking. Pretty neat feature. In the other diagrams, you're going to see X and I think it's EX. There's a couple of different relays that are triggered by the X terminal for so many more consumers. And that gets really complicated. This is just the simple stuff. So there's some other circuits we'll go on to next week. I'll continue on some more things about how some of the other systems work. In the comments, let me know if there's a certain circuit you're working with or you want a little more information on one particular circuit. If you're having trouble with your AC, if you're having trouble with anything else, seatbelt warning or the concealed headlight motor, that's a fun one. We get into something like that. And that's it. Let me know, or let me know if my style of showing you what to do or how this all works is kind of annoying, or how you want me to handle this. I'm not a teacher. I'm just doing the best I can. So let me know in the comments if you think I can do this a better way, or if you want more information on a certain circuit.